Let's discuss the slope of a line, also sometimes referred to as the gradient of a line. The slope or the gradient of a line is defined as the trigonometric tangent of the angle formed by the line with the positive direction of the x-axis in a counterclockwise direction. Let's try to understand this graphically. So as you can observe here, we have the Cartesian coordinate system, and here I'm considering two lines. Let's say one is line L1 and L2. Now clearly both L1 and L2 forms an angle with the x-axis. So it's very important. We always check with which axis the line is making an angle, and that's always going to be the x-axis. And for figure number 1, let's name it. For figure number 1, if we consider line 1, it's making an angle theta with the positive direction of x-axis. That means we'll have to start from the x-axis positive direction and go in the counterclockwise fashion. The angle that it makes, let's call it theta 1, and if we take the tangent of that particular angle, tangent of theta 1, this is going to be the slope of the line L1, and generally we denote the slope by the letter m in lowercase. So m1 is going to be tangent of theta 1. Similarly for L2, which is the second line, how to measure its angle with respect to the x-axis? So we will consider the angle theta 2 made with the positive direction of x-axis in the counterclockwise direction. If we take the tangent of that angle, that means tangent of theta 2, that's going to give us the slope of the particular line L2. Now coming to the other figure, so here we have figure number 2. Here also we have two more lines, so let's call them L3 and L4. Now clearly L3 and L4, as we can see, it also intersects the x-axis, and we can see here that it is also going to make some angle with it. So as usual, we'll have to go from the positive direction of x-axis in the counterclockwise fashion. So it's going to make an angle theta 3 with the line. Similarly for L4, it's going to make an angle theta 4 in the counterclockwise direction. So if we take the tangent of angle theta 3, so that's going to be the slope m3 of line L3. And if we take tangent of angle theta 4, that's going to be the slope of the line L4, and we're going to denote it by M4. Now we know that for the form figure number 1, theta 1 and theta 2 are both acute angles. So whenever theta 1 and theta 2 are acute angles, then the tangent value is always going to be positive. So we can say that M1 as well as M2, both of them are going to be positive values. So that means we have a positive slope if angle theta 1 as well as theta 2 are acute angles, meaning their value is less than 90 degree. However, for figure number 2, if we consider the line L3 and L4, clearly theta 3 and theta 4 are obtuse angles, and if they're obtuse, then the tangent of those angles theta 3 and theta 4, that's going to be negative, which means M3 as well as M4, they are both going to be less than 0. That means they are going to be negative. So whenever we have a negative angle, we must immediately know that our angle theta is an obtuse angle, whereas if it is an acute angle, then the slope is going to be positive in nature. Let's take the help of an example. Let's say we have theta given by 60 degree. A line, that means it's making an angle 60 degree with the positive direction of x-axis in the anti-clockwise fashion. Then the slope of that line, slope which we are going to denote by m, that's simply given by tangent of angle 60 degrees. Now what's the value of tangent of 60 degree? That's square root of 3. Now clearly we observe that that's a positive value. We're getting a positive value because 60 degree, which is an acute angle. Now let's say if we take a bigger angle, let's say double of 60 degree, that's going to be 120 degree. Then we can define the slope of that particular line. So let's call this as M1. This will be M2. So M2 will be then tangent of 120 degree. The question is, what's the value of tangent of 120 degree? What we can do, we can always simplify this value. Tangent of 120 is nothing but 2 times 90 degree. So that's 180 minus 60 degrees. Now 2 times 90 means we have an even multiple of 90 degrees. So whenever we have an even multiple, tangent is going to remain as tangent function, but the new angle is going to be 60 degree instead of 120. So we have tangent of 20 degree, but then again we'll also have to check in which quadrant the angle 120 lies. Clearly 120 is going to lie in the second quadrant because it's greater than 90 degree and less than 180 degree. In the second quadrant, the tangent function is a negative value. So we get negative tangent 60 degree, and this is going to give us negative square root of 3. Clearly, we see that our slope is giving us a negative value, which means that our angle must be an obtuse, and that's true. We've chosen an obtuse angle, angle greater than 90 degree. What about if we choose theta as 0? So if theta is 0 degree, then what will be the slope? Then the slope m3 will be simply equals to tangent of 0 degree, and tangent of 0, that's 0. This is actually a line which is parallel to the x-axis. So whenever we have a slope equals to 0, we can say that the line is going to be parallel to the x-axis. Okay. Any line that's parallel to the x-axis automatically is going to give us a 0 slope, whatever if it is 90 degree. If theta is 90 degree, then what about the slope? Then our slope, let's call it m4, is given by tangent of 90 degree. Now what's the value of tangent 90 degree? That's undefined. Tangent of 90 degree cannot be defined. So that means the line is simply parallel to the y-axis, or you can say perpendicular to the x-axis. So whenever this is the case, any line which is perpendicular to the x-axis or the other way around, it is parallel to the x-axis, y-axis, let's write it down, or parallel to the y-axis. In that case, the line is going to have a slope of 90 degree. Now this is actually theta. The theta is 90 degree. Okay, let's try to understand it graphically. So here we have two lines, L1 and the other line is L2. Now L1, if we look at the line L1, this line is parallel to the y-axis, and if we try to find out its angle that it makes with the x-axis, that's going to be 0. So since it is 0, it's making an angle 0, then we can say the slope of line L1, that's simply equals to 0. So graphically it makes sense. Any line that is parallel to the x-axis has to have a slope of 0. What about line L2? Clearly L2 is making an angle 90 degree with the x-axis. So it's perpendicular to the x-axis, or in other words we can say it's parallel to the y-axis. In that case, the slope of that line, so slope of L2, that's simply going to be undefined. So we don't have any slope for a perpendicular line. So if we want to understand it from a very practical term, think about a car that is rolling, or a bike that is rolling flat road. That means a road which has a slope of 0. It will be very easy for that particular car to move from one position to the other position. It becomes extremely easy if it has a slope of 0. However, let us consider a car which is moving along the x-axis, and it moves towards the line L2. When it reaches the line L2, this is actually line 2 can be thought of as a wall. So it becomes very difficult for the car to go beyond that wall. It is going to halt. Or in other words, you can say it cannot even move upwards along the y-axis. That's because it's simply not possible. So that's why we have a slope of undefined. So that means slope of perpendicular lines, lines which are perpendicular to the x-axis, or perpendicular or parallel to the y-axis. These type of lines are going to have undefined slope. So now that we have defined the slope of a line, let's try to understand how we can compute the slope of a line if the coordinates of its endpoints are given to us. Let's say we have a line segment, and we're going to name this line segment with the endpoints as A and B. Now we'll also define the coordinates of the endpoint. Let's say the coordinates of the endpoint A, x1 and y1, and the coordinates of B are x2 and y2. Now what will be the slope of this particular line? Okay, so let's find out the slope of this line. All we have to do is drop a perpendicular from point A as well as from point B on the x-axis. So from point A, we are dropping a perpendicular on the x-axis. Let's say it meets at the point C, and perpendicular drop from point B along the x-axis meets it at point D. And similarly, what we'll do, we'll also drop perpendiculars from point A and point B on the y-axis as well. So let's say these two perpendiculars meet the y-axis at E and F. Our goal will be to determine the slope of the line AB. Now to define the slope of the line, what we'll do, we're going to extend the line segment AB through A such that it meets the x-axis at some point G. Now we'll also extend the line EA through A such that it meets the line BD at H. Now clearly, if we want to find out the slope of the line AB, it's the same as taking the angle that it makes with the positive direction of x-axis. So this is the angle theta. If this is angle theta, then BAH, this is also going to be angle theta. So that means we'll have to obtain the value of tangent of this angle theta, and that's going to give us the slope. So our slope is going to be simply equals to tangent of the angle BAH. Now, in the right angle triangle BAH, we can easily define tangent of that angle. So tangent is defined as the perpendicular BH divided by the hypotenuse, which is AH. Fine. So that means the slope will be simply BH over AH. Now what is what is BH? BH is nothing but the length BD minus HD. And if we want to define AH, AH is nothing but the length HE minus EA. Fine. So we can also rewrite the denominator portion, the numerator, let's keep it intact, BD minus HD. HE, now you can see that HE is nothing but the line GD because they're parallel to each other. So in place of HE, we can replace it with GD. From it, we can, we're subtracting EA, but EA is equivalent to GC. The reason why we're doing this, because what is BD? BD is nothing but the height of point B from the x-axis, and that's going to be Y2. Minus HD, HD is nothing but, it is actually AC. So that's the height of point A from the x-axis as well. So that's going to be Y1 divided by GD minus GC. So GD, that's the distance of point D from the origin. So that's going to be equivalent to distance of point B from the y-axis, which is going to be x2. Minus GC, so GC is going to be distance of point A from the y-axis, so that's going to be x1. So this is the formula for obtaining the slope of a line if the coordinates of the two endpoints are given to us. It's the difference of the y coordinates divided by the difference of the x coordinate, or in other words, we can also write it as the difference of the ordinate value, that's the y coordinate value, divided by the difference of the abscissa. So this is how we can define the slope of any line given its two endpoints. Let's try to understand this problem with the help of an example. So we need to determine the slope of a line. Passing through the points 3, 2 and -1, 5. So let's obtain the value. So slope, which is denoted by the letter m in lowercase, that's simply given by y2 minus y1 divided by x2 minus x1. So since we are provided with these 2 points 3, 2 and the other point -1, 5, so let's say at 3, 2 corresponds to x1, y1 and -1, 5 corresponds to x2, y2. So what will be the value of y2? So that's 5. From here we have to subtract y1. So y1 corresponds to the value 2 divided by x2 minus x1. So here x2 is -1. From here we subtract x1, which is 3. So we have 5 minus 2. That's going to be +3, -1, -3, that's going to be -4. So that means the slope of the line is -3 over 4. Now we'll move on to another topic. That means if we are given two lines and let's say both of the two lines are intersecting, then what is going to be the angle of the angle made by the two lines? So here we have two lines, line L1 and the other one is line L2. As we can observe here that these two lines are intersecting each other at a point, let's call it point P. And also once it intersects, it's also forming an angle between them. And let's call this angle as angle theta. The question is, can we define this angle theta or can we measure this angle theta? Provided the slope of the lines L1 and L2, both of the two lines, that is known, that value is known. Okay, so how do we proceed? So let's say we begin with line L1. Clearly, in order to define its slope, we have to find the angle that it makes with the positive direction of x-axis in the anti-clockwise fashion. So we're going to call this as angle theta 1. If we take the tangent of that angle theta 1, we can easily find out the slope of line L1. Similarly, for line L2, we're going to define its angle that it makes with the positive direction of x-axis in the anti-clockwise fashion. And when we take the tangent of angle theta 2, we're going to get the slope of line L2. Okay, fine. Now, we know that theta 1, this is the, if we consider this as triangle PAB, so in triangle PAB, clearly angle PB, let's call it PB, this is a C, PBC is an exterior angle. Now, if it is an exterior angle, then immediately we can say that the exterior angle theta 1, this must be equals to the sum of the two opposite interior angles, and those are nothing but theta added to theta 2. Fine. If this is true, then we can rewrite theta as theta 1 minus theta 2. Fine. Now what we'll do, we're going to apply the tangent function on both sides. So we get tangent of theta. This will be equals to tangent of theta 1 minus theta 2. Fine. So that means we have tangent of theta. This will be equals to, do not make the mistake of writing tangent theta 1 minus tangent theta 2, because tangent is not distributive in nature. So that means we'll have to apply the trigonometric identity. So in order to expand tangent of theta 1 minus theta 2, clearly theta 1 minus theta 2, that's a compound angle. This is a difference of two angles. So if we expand tangent of theta 1 minus theta 2, then we will have to use the fact that, let's say, if we have tangent of angle A minus B, so that's nothing but tangent of angle A minus tangent of angle B whole divided by 1 plus the product of tangent A and tangent B. Now in our case, A corresponds to theta 1 and B corresponds to theta 2. So we are going to get tangent of theta 1 minus tangent of theta 2 divided by, we have 1 plus tangent of angle theta 1 times tangent of angle theta 2. Now what is tangent of theta 1? Tangent of theta 1, that's nothing but the slope of line L1. So that means we can replace tangent of theta 1 with M1. And what is tangent of theta 2? Tangent of theta 2, that's the slope of the other line, which is M2. So that means tangent of angle theta, that will be equals to M1 minus M2 divided by 1 plus M1 times M2. Meaning, if we know the slope of the two lines, L1 as well as L2, then we can use this particular formula. This will help us obtain the value of tangent of theta. And then what we can easily do is we can take the inverse tangent function to easily obtain the value of angle theta. So this is how we can define the angle between two lines, provided the slope of the two lines are given to us. Fine. Now in this case, clearly we have considered theta to be an acute angle. So here theta is acute. Now theta could be obtuse as well. What about if we have chosen this particular angle? Then this is, let's call it theta prime. Now how do we define theta prime? Now clearly we know that theta plus theta prime, this will be equals to pi, because it's a supplementary angle, theta added to theta prime. So that means if we want to define theta prime, that's simply pi minus theta. So let's do one thing. Let's try to find out the value of tangent of theta prime. So tangent of theta prime will be simply equals to, of course, this is the same formula that we'll be using, M1 minus M2 divided by 1 plus M1 times M2. If we replace the value of tangent of theta prime with pi minus theta, then this will be equals to, we have M1 minus M2 divided by 1 plus the product M1 times M2. So what's tangent of pi minus theta? That's nothing but simply negative tangent theta. So that will be equals to M1 minus M2 divided by 1 plus M1 times M2, or we can say that tangent of theta will be equals to negative of M1 minus M2 divided by 1 plus M1 times M2. Fine. So we can define either this angle between N1 theta, angle between L1 and L2, or we can also define in terms of theta prime. In both the case, if we combine this particular formula with this formula, then we get tangent of theta will be equals to the absolute value of M1 minus M2 divided by 1 plus M1 times M2. So this is how we can define the angle between any two lines. So once we take the absolute value, then theta can be either acute or it could be obtuse. So we'll get the value accordingly. Now this particular formula is an extremely important formula, because immediately from this formula we can get two very important results. So let's say, let the angle theta be equals to 0 degree. If theta is 0 degree, then what is tangent of theta? So tangent of theta will be simply tangent of 0. So that means we have tangent of 0 given by the absolute value of M1 minus M2 divided by 1 plus M1 times M2. And what is tangent of 0? That's simply 0. So we have 0 equals to M1 minus M2 divided by 1 plus M1 times M2, and we'll be taking its absolute value. Now clearly this particular fraction M1 minus M2 or 1 plus M1 times M2, this is equals to 0. This is only true whenever M1 equals to M2. What does the angle theta equals to 0 degrees signify? Theta equals to 0 degrees signifies that the two lines are making an angle 0 degree with each other. So either the two lines could be lying on top of each other or they are going to be parallel to each other. And we're getting the result that both of them are going to have the slope as equal slope. So that means we can say that two parallel lines have got an equal slope. That's always going to be true. The slope of the slope of two lines are equal, that also tells me vice versa. If the slope of two lines are equal, then those two lines are going to be parallel. So, or vice versa, we can say if the slope of two lines are equal, then the two lines are parallel to each other. Fine. So this is a very important result that we have obtained. So m1 equals to m2. Now what we'll do, we'll take theta to be equals to 90 degree. So let's see what happens when we take theta equals to 90 degree. Now clearly tangent of theta, which is tangent of 90 degree, that's going to be undefined. So undefined, that's because tangent of 90 degrees is actually the ratio of sine 90 degree to that of cosine of 90 degree. So sine 90 degree, that's 1, cosine of 90, that's 0. We have a division by 0, that's why tangent of 90 degree is 0. However, we have already defined that this is equals to the absolute value of m1 minus m2 divided by 1 plus m1 times m2. We can say that this implies that the denominator portion 1 plus m1 times m2, this must be equals to 0, or we can say m1 times m2 equals to negative 1, or we can interpret it as m1 equals to negative 1 over m2. This means that if the product of the slope of two lines is negative 1, this means that the two lines are perpendicular to each other. And the other way around will be, if two lines are perpendicular to each other, then it immediately follows that the product of their slope must be equals to negative 1. This is an extremely important result, both this one and the other one, when both the two slopes are equal, and we will be able to solve a multiple number of problems in the subsequent lectures. Let us understand all of this concept with the help of few numerical problems. Let us begin. So we need to find out the angle between AB and BC. That means these are two lines which are formed by joining point A and point B, and the other line will be from joining point B and point C. The coordinates of the endpoints of the two lines are given to us. So let us begin. So let's say we have point A with coordinates negative 2, 1, and we have another line with coordinates B. So here B has the coordinates 2, 3. Let's join point A and point B with the help of a straight line. Now it's also given here that we have another point C. So C has the coordinates negative 2, negative 4. We're going to join B and C. Let's say we are joining B and C. Now what we'll do, we're going to extend the two line segments such that they are making an angle between them. Let's call this particular angle as theta. It could be either this angle or it could be the other angle, theta prime. Doesn't matter. We have one common formula to obtain the angle. Okay, now before finding out the angle, we'll have to obtain the slope of both the two lines. So let's begin by finding out the slope of the line AB. So that will be, we'll have to take the ratio, and the ratio, the numerator portion will give us the difference of the ordinates, 3 minus 1, and the denominator, we have difference of the abscissa. So that will be 2 minus negative 2. So that means we have 2 over 4, which is equals to 1/2. And let's also find out the slope of the other line. So slope of BC, so that's going to be equals to, we have 3 minus negative 4, that's the difference of the ordinate, and in the denominator we have the difference of the abscissa. So that's 2 minus negative 2. So that's going to be 7 over 4. Now that we have the slope, we're going to name the slope for the first line AB as m1, and for the line BC, we are going to name its slope as m2. Now let's find out the angle. So first we'll take the tangent of that angle theta. We'll take the absolute value. We have m1 minus m2 divided by 1 plus the product, half times 7 over 4. Okay, so this is going to give us a value equals to absolute value of 2 over t. So this is the tangent of that angle theta. But we are asked to find out the angle, not the tangent of that angle. So theta will be equals to, all you have to do is take the inverse tangent function. So it will be tangent inverse of 2 over 3. Fine, absolute value of 2 over 3. So that's the angle between the two lines AB and BC. Let's move on to the next problem. Problem number 3. we need to show that the 3 points A, B and C are the vertices of a right angle triangle. How do we show that? And the quickest way to show that the 3 vertices form the vertex of a right angle triangle, all we have to do is we can use the Pythagoras theorem. However, we're going to take a different approach this time. So what we will do, we'll try to find out the slope of, let's say, AB. We'll find out the slope of line AB and we're going to name it as M1. So what will be the slope of line AB? So in the numerator, we'll take the difference of the x coordinate. So that's 5 minus 4. And in the denominator, we take the difference of x coordinates. So that's 3 minus 4. Fine. So 5 minus 4, that's positive 1. 3 minus 4, that's negative 1. So M1 is a value negative 1. Then we will try to find out the slope of the line AC. And let's call it M2. So AC will be, so first we will take the difference of the y coordinate in the numerator. So we have 4 minus negative 1. Divided by, then we will take the difference of the x coordinate. So we have 4 minus negative 1 in the denominator. So that gives us a value 5 over 5. So 5 over 5 is simply 1. Now, if we take the product M1 and M2, this is giving us a result negative 1 multiplied to 1, which is simply equals to negative 1. This is a condition which tells us that the line AB is perpendicular to line AC. That means, so what we have here is the line formed by joining the points A and B, and we have another line formed by joining the points A and C. And clearly AB is going to be perpendicular to AC. That's because the product of the slope of these two lines AB and AC, they're perpendicular to each other. And if we join B and C, we're going to get a triangle. And clearly in a right angle triangle, we have one of the angle at 90 degree. And this is what we can show, that clear A, B and C forms the vertices of a right angled triangle. Let's do one more problem. Problem number 4. We need to show that the points A, B, C and D are the vertices of a square. So let us begin. So we consider a quadrilateral A, B, C and D. The coordinates of the vertices are given to us. So A has the coordinates 4, 3. B has the coordinates 6, 4. C has the coordinates 5, 6. D has the coordinates 3, 5. Now, in order to show that it's a square, first we'll have to show that the sides are equal. To find out the sides of the square, we'll have to use the distance formula. So let's begin by first obtaining the length of side AB. So we'll take the square root. Underneath the square root, we need the difference of the x coordinate. Then we are going to square it and then add it to the difference of the y coordinate and then square it as well. So let's find out the difference of the x coordinate. So we have 6 minus 4 added to 4 minus 3. So this is going to give us a value square root of, so 6 minus 4, that's 2, 2 squared, that's going to be 4, and 4 minus 3, that's 1, squaring it gives us 1, so 4 plus 1 will be square root 5. So we have square root of 5. Similarly, we'll find out the value of BC. So BC is going to be, we'll take the square root. Underneath the square root, we have difference of the x coordinate. So that's negative 1, square it, and then add it to the difference of the y coordinate. So that's negative 2 squared. So this is giving us a value square root of 5. Then CD, so CD will be equals to, we'll take the square root. Underneath the square root, we have negative 3 squared plus negative 1 squared, which gives us a value square root of 5. Then DA, that's going to give us a value equals to, we have square root of positive 1 squared plus negative 2 squared. So this is giving us a value square root of 5. So we have AB equals to BC equals to CD equals to DA. So we have all the sides of the quadrilateral are equal to each other. So the sides are equal, but we are still not sure if it is a square because it could be a rhombus, because a rhombus also has all the sides are equal. So what we'll do, we'll show that two sides are, that means side AB is perpendicular to BC. Similarly, side AD will be perpendicular to CD. The two adjacent sides are going to be perpendicular to each other. So let's begin by first finding the slope of line AB. So slope of line AB, this will be equals to, let's call it M1. This will be equals to, so we need the difference of the y coordinate in the numerator, 4 minus 3, divided by the difference of the x coordinate. So that's 6 minus 4. And this will be equals to 1/2. Fine. Then we'll find out the slope of BC. Slope of BC, that's going to be 6 minus 4 divided by 5 minus 6. So 6 minus 4, that's positive 2. 5 minus 6, that's negative 1. So our slope comes out to be negative 2. Fine. Now let's call the slope of BC as m2. Clearly, if we say m1 multiplied to m2, we get half multiplied to negative 2. So that gives us a value negative 1. This means that AB is perpendicular to BC. Let's try to obtain the slope of the other two sides as well. So we'll begin by first obtaining the slope of side CD. We're going to call it M3. So this will be equals to, we'll take the difference of the y coordinate. So that's 5 minus 6, negative 1, divided by the difference of the x coordinate, 3 minus 5. So that's going to be negative 2. So we have slope equals to 1/2. And then finally, we need to find out the slope of the fourth side DA. Let's call it M4. So M4 will be equals to, so we need the difference of the y coordinates, 3 minus 5, that's negative 2, divided by, let's write down 3 minus 5 divided by 4 minus 3. So this is giving us a value negative 2. Now if we take the product M3 times M4, so we're going to get negative 1. So M3 times M4 means we can say that AD is perpendicular to CD. So here AD is perpendicular to CD. Fine. And clearly M1, that value is equals to M3. So M1 equals to M3. That means that this implies that AB is parallel to CD. And we have M2 equals to M4. Both have a value of negative 2, which implies that the side BC is parallel to side DA. So all the conditions are met. That means the two sides of our two sides are parallel to each other. The opposite sides are parallel to each other. Then we have all the sides are of equal length. Then each two adjacent sides are at 90 degrees to each other. So this, all of these conditions tells us that there's ABCD is the quadrilateral that we choose is indeed a square. So this is how we can use the idea of a slope to solve our problems.